Hello everyone, myself Sai Prasad, Alexa in Alphabet High School and the Junior College. Welcome to a series of the lectures of Intermediate Second Year Maths A. We started a discussion with a chapter, Permutation and Combination. What did we learn? We just had a basic introduction about what is a permutation, and we did few problems of NPR ka formula, right? And also we did some of the digits, right? Fine. And with the continuation of that, let us learn how do we arrange a given element with respect to the condition. Okay, look at the first question for today. The question is given as find the number of ways of arranging 6 boys, 5 girls in a row so that all girls sit together, no 2 girls sit together, boys and the girls sit alternately, and no 2 boys sit together. So we have to write how we can arrange this kind of conditions. Okay, just tell me what are the what are the items we have? 6 boys, 5 girls. These are the objects. Okay, just consider them as objects. How do we arrange? Right, just see here, he is telling that all girls sit together. Let me take the first one. All girls sit together. So let me write how many girls? 6 girls, 5 girls. 1, 2, 3, 4, 5. These all girls sit together, and remaining 6 boys have 6 positions. 1, 2, 3, 4, 5, 6. Okay, and let us consider this can be either placed here or here or here or here or whatever, wherever we say. Okay, so clearly we can tell that this completely is a single place. Second, third, fourth, fifth, sixth and seventh. We have 7 places and 6 objects. Obviously the answer will be 7 factorial. Right? We have 7 positions and 7 objects. So it will be 7 factorial. And inside this box we can arrange this 5 girls. They themselves, so obviously it is 5 factorial. Clear? Did you understand? Once again, see here, we have considered all the set of girls together as a single object, so we can place them in a single place. And we have 6 more boys, so 6 boys, 1 girl's co-object, all together will have 7 objects in a 7 positions. Obviously that can be 7 factorial. Again, there are 5 girls sitting in the single box, they can be arranged themselves, so it can be 5 factorial. Done? Fine. Look at the next question. No 2 girls sit together. Okay, let us say, let me put girls separately. 1, 2, 3, 4, 5. Okay, and there are 1, 2, 3, 4, 5, 6 positions for boys, 2, 3, 4, 5 girls, and there are 6 positions to sit for boys. 1, 2, 3, 4, 5, 6. Right? Yes or no? No 2 girls are sitting together. How many girls do we have? 5. So I have arranged the girls before. Okay? Yes or no? Do you understand? Or else simply you can arrange first boys. 1, 2, how many boys do we have? 6, right? 2, 3, 4, 5 and 6. So we will have 1 more position. Let me arrange all boys first. So obviously how many girls do we have? 1, 2, 3, 4, 5, 6, 7 positions we have, and we have 5 girls. Obviously we can arrange as 7p5. Okay, 7p5, and we have to arrange the 6 boys in their 6 positions. Is it okay? You do understand? Once again, see here, he is telling that no 2 girls should sit together. So obviously I will arrange all the boys first, then I will arrange girls. Okay, we will give 1 space in between boys. Okay, fine. Look at the next question. Boys and girls sit alternatively. So let me say There are 6 boys. Let me start with a boy, boy, girl, boy, girl, boy, girl, boy, girl, boy and girl. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I mean 1, 2, 3, 4, 5. Okay, 5 boys and 1 more boy. So this can be a combination. So how do we write? In 6 places we have placed 6 boys. In 5 places I have placed 5 boys. Obviously that is nothing but 6 factorial by 5 factorial. If you want to simplify, it's okay. Even if I leave it like that also, it's fine. Clear? Next, 4th question. No 2 boys sit together. So whom should we arrange first? We have to arrange girls first. So let me arrange girl, 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 girl. 1, 2, 3, 4, 5, 6. I have 6 positions for boys and 5 positions for girls. So the arrangement will be like 5 factorial into 6 factorial. Is it clear? Did you understand? The main theme here is just try to understand the question and arrange in such a way that everything should be arranged and nothing should be side by side. Clear? Did you understand? Shall we go on to the next problem? Let's do. Look at the next question here. Find number of 4-digit numbers that can be formed using 1, 2, 5, 6, 7. Just tell me this answer first. What is n? I have 5 digits here. 1, 2, 3, 4, 5. How many digit numbers we need? 4-digit numbers. So the number of numbers formed. Number of numbers formed can be nothing but 5p4. 5 factorial by 4 factorial, which is 5 factorial by 5 minus 4 factorial, which is 120. Done. So the discussion is done for that question. Next, how many of them are divisible by 2, 3, 4, 5, 25? So how do we arrange? We have numbers, 5 numbers, which is 1, 2, 5, 6, 7, and we have 4 positions. Okay, what to do if the number is divisible by 2? Just tell me. How do you say a given number is divisible by 2? That the ones digit number should be divisible by 2. So out of our numbers, only 2 and 6 are divisible. Once see here, let me tell. For the first question, I have 5 positions. Okay, 1, 2, 3, 4, 5. Out of these 5 positions, the 5th position is booked by what are the 2 digits? 2 or 6. Okay, so here 2 positions are fixed. That is, out of 2 elements, I will arrange 1, which is nothing but simply 2p1. Still, I will be left with 4 digits and I'll have how many? Sorry, it is only 4-digit number, right? So it is only 4-digit number. I will be left with 4 more digits and 3 positions. So the number will be 4p3. Any question? Is it right? Once again see here. Here I have 4 positions and 5 elements to be arranged. Out of 5, 2 and 6 can be placed in this position. Let us say 2 is placed. Still we will have 4 elements, that is 1, 5, 6, 7. Right? Let us say 6 is placed, even though we will have 4 elements, 1, 2, 5, 7. Because there is no repetition. Remember, no 2 digits are same. Okay? Fine. After removing this term, we will have 3 more places. We will have 4 objects. That will be 4p3. So that is nothing but 2 into 4p3 is 4 factorial by 1 factorial, which is 432. 4 3s are 12, 12 2s are 24. So obviously the answer will be 48. Clear? Until unless you have a heavy practice, you can't do this fastly. Clear? Fine. Look at the next question. It is divisible by 3. So when do we see the 2 numbers are divisible by 3? Just count 1, 2, 5, 6, 7. 1 plus 2 plus 5 plus 6 plus 7. How much is it? It is 1, 2, 5, 6, 7, 3, 8, 14, 21. Obviously it is divisible by this thing. Okay, so these 4 positions we have to replace the number in such a way that just by removing one number you can take. Okay, the answer we are getting 21, it's fine. If I remove 1, it will not fine. It is not fine. If I remove 2, we can't arrange. If I remove 2, we can arrange. Sorry, 19 also it is not divisible. If I remove 5, we can't get, if I remove 5, we will get 16. It is not possible. If I remove 6, it is possible. So, in how many ways we can arrange it? So, only if I remove 6, we can get it as 1 plus 2 plus 5 plus 7. How much is this? 7, 14, 15. It is divisible by 3. So, we can have only this 4 digits. We can't remove any number. Why? We are not getting the exact number which is divisible by 3. So, only these 4 numbers, 4 positions. Answer is 4 factorial. Right? These things will be easy if you understand. Third, divisible by 4. How do we know that a given number is divisible by 4? 1, 2, 3, 4. These 2 numbers should be put. By what numbers? By divisible by 4. Then only we can get. By using those numbers, what are the numbers we can get in 4 table? 4 3s are 12, 4 4s are 16, and the next 20 is not possible, 24 not possible, 28 not possible, 32, 36 now, and the next 36, 40, 42 not possible again, 36, 40, 44, 48, 56, right? And the next 52 is possible, 52, 56, next still 60 not possible, 64, 68, 72 is possible again, right? After that 76, that's it. That is the maximum we can get. So, by which 2 numbers we will get it is divisible by 4. Now just check, whatever it is, we will have only 2 numbers in that position, right? 2 numbers are done. Other than 2, we will have remaining 2 numbers, again 2 factorial. Is it right? So how many numbers we can take here? We will have 6 numbers into, if I remove 2 numbers, I will be left with 3 elements, out of which we have to fill 2 places, which is 3p2. What is 3p2? 3 factorial by 1 factorial, that is 6 into 3 into 2, that is 3 2s are 6, 6 6 are 36. Right? Next, divisible by 5. This is still more simple. If a number is divisible by 5, then the last number either should be 5 or 0. Obviously, we have only 5. We will arrange that 5. We will be left with 4 more elements, 4p3. Whatever the answer it is, that is 4 factorial, that is 24. That is the answer. Is it right? See here, 4p3, that is, we'll have 4 elements in 3 different positions. Okay, fine. Next, the 5th one. How do we say a given number is divisible by 25? What are the combinations we can get here? 25 and 75. Yes or no? We'll get either 25 or 75, which means only 2 numbers. If I remove these 2 numbers, I will be left with 3 more digits, 2 places. So it is 3p2. 2 into 3 factorial, that is 3 2s are 6, 6 2s are 12. Did you understand? Right? You got a basic idea of how do we do it. Once again, let's rewind it. First thing, he is telling that it should be divisible by 2. If I want it to be divisible by 2, either the last number should be either 2 or 6. Clear? So I will be left with 3 more elements. I will be left with 4 more digits. So it is 4p3 and into 2. Done? Fine. If I want it to be divisible by 3, if I add all numbers, I am getting 21. Which number I have to remove so that I should get a valid 3 table ka number? If I remove 1, I will get 20. Not possible. If I remove 2, I will get 19. Not possible. If I remove 5, it is 16. Still it is not in 3 table. If I remove 6, yes, I can get 15. If I remove 7, even though we will get some like 14, still it is not possible. So obviously 15 is a valid 3 table number. So we can write 1, 2, 5, 7 as 4 digit, 4 places, 4 factorial. Okay. Next, 4 table, divisible by 4. So the last 2 digits must be divisible by 4. So what are the combinations we can get in 4 table? Here is 12, 16, 52, 56, 72, 76. 6 numbers we can arrange. If I put those 6, 2 digits will be removed. I will be left with 2 more digits. So I can write it as 3 elements, 2 digits, 3p, 2. So answer will be 36. Right? Next. In the 4th question, it is divisible by 5. In the 5th position, we should get 5 or 0. We have only 5. Just place it there. 5 are done. 4 elements, 3 positions, 4p3. That is the answer. Right? Next, 25. The last 2 digits must be divisible by 25. Here we can get 25 or 75. Because 65 and 51 are, 65 and 15 are not in 25 table. Yes. So these 2 numbers, that's why I have written into 2. I will be left with 3 elements, 2 positions, 3p2. That will be my answer. Okay. Did you understand? Shall we move on to the next problem? Let's do. Look at the next question here. He is asking us find the number of ways of arranging 5 different maths books, 4 physics books, 3 chemistry books, as that books of the same subjects are together. So how? We will put 4 maths books together, 4 physics and chemistry books together. Maths, physics, chemistry. So how many units we have? Total 3 units. There are 5 maths books, 4 physics books and 3 chemistry books. Right? So there are number of units is 3. So the arrangement of 3 units is 3 factorial. Arrangement is 3 factorial. Right? Next, how many maths books? Number of maths books, it is 5. Arrangements, we can arrange 5 books inside itself, 5 factorial. Right? Next, physics books, number of physics books is 4 factorial. The arrangement, 4 numbers, the arrangement is 4 factorial. What about chemistry books? Number of chemistry books, there are 3. So we can arrange like 3 factorial. Right? That's it. The answer is done. Therefore, total arrangement is given by 3 factorial into 5 factorial into 4 factorial into 3 factorial. I can write this also directly. Yes, we have 3 different units, so we can shuffle and arrange these 3 elements as 3 factorial. Inside each unit, maths ka 5 books, we can arrange them as 5 factorial. Physics 4 books, we can arrange them as 4 factorial. Chemistry, we have 3 books, we can arrange it as 3 factorial. Is it right? So the total answer will be like 3 factorial, 5 factorial, 4 factorial and 3 factorial. Right? Did you understand? Fine. What all we discussed today? We discussed all kind of arrangements today. heavily. That is one question of letters, one question of boys and girls, one question of this kind of simple arrangement, one question is of numbers, right? In the next session we'll have a typical arrangement of names, that is how many different kinds of names we can prepare by 4 or 5 alphabets. Okay, that kind of simple and interesting things we are going to learn in our next session. Clear? Fun. This is for today. Let us meet in the next session with the more problems of permutation and combination. Thank you.